Hello everyone. So my name is Jean-Claude Niag, and I'm going to present about the different questions on ELISA and vaccinations. So I'm going to start on the ELISA. As ELISA is the enzyme linked immunosorbent assay that is actually used to detect and quantifies the antibody as well as the antigens. So here for the question number 36, as we asked, I'm going to tell you more about the difference between sandwich ELISA, even indirect ELISA. So I'm going to start on this sandwich ELISA. uh, as you can hear, there is sandwich. As you know, the sandwich, there is even anything that's between two things. So for this sandwich eraser, it is the antigens that is between different two antibodies. So here, by the difference, I'm going to look on every aspect that I'm going to consider by purpose of sandwich and indirect ELISA detections, capture mechanisms, procedure, applications, even sensitivity. So by starting on the purpose, sandwich ELISA it diagnoses or has a purpose for detecting the specific antigens. That antigens it detects it's between two different antibodies, and even indirect ELISA it detects the specific and quantifies the antibodies. So for indirect ELISA, there is two two different subclasses as primary and secondary indirect ELISAs. So by continuing on the capturing mechanisms for the sandwich ELISA, it uses a capture antibody to bind the antigens. Actually, it captures the antibody and bind it to the antigens in the wells. And for the indirect ELISA, the coats the coated plates with antigens to bind antibodies. The antigen on the coated plates will bind to the antibodies. And so the procedure for the preparation for those sandwich eraser and indirect eraser, the procedure we look for the antigen is sandwiched between two antibodies, like how I've said before. Those antibodies antigens is between two antibodies. And for the indirect ELISA, primary antibody bind to the antigens and the secondary enzymes linked antibodies detects it. That's where the antigens will bind to the antibody will bind to the antigens. Then after the antigen bind to the antibody, it will not be activated where the enzymes it will come as well as with its substrate, and it will be activated. Then there will be the chromogens that will give out the colors for the indirect antigens. So for the applications, for sandwich eraser, measuring cytokines, hormones, or viral proteins. Actually, this sandwich eraser will measure cytokines. Cytokines are those ones that help for the immune response, where they will activate the T helper cells that will fight against the invaders on the bodies. Even those hormones as well as the proteins. And for the indirect eraser, there is diagnosis. It will use it to diagnose infections by detecting the antibodies. These indirect erasers will use where we are diagnosing those infections. For the sensitivity, this is the times or the long it will take for the antibodies or the antigens to be sensitive or to be activated. There is high sensitivity due to dual recognitions for the sandwich eraser. And for the indirect eraser, the relative less sensitives. For indirect erasers, it is very less sensitive for the detections of the antibodies. And I may continue for the question number 37 for the application of ELISA in clinical practice. This ELISA is normally used in clinics where you are diagnosing different pathogenics. Um, ELISA is widely used in diagnostic researches and even public health. But for the first, we will look for the diseases diagnosis. Uh, ELISA we use it to detect pathogens, those diseases causing HIV, hepatitis B surface, viruses, COVID-19, and it will use it to identify autoimmune diseases as like rheumatoid arthritis that will attack the joints. Even for allergic testing, for measuring the immunoglobulin E levels, where those are during the allergic reactions, the ELISA can be used to detect that immunoglobulin that will be suppressed as allergic for the allergic reactions. Uh, Hormone quantifications. ELISA used to measure insulin, cortisol, or thyroid hormones. Insulin as the protein, insulin as the proteins Insulin has the proteins that help for the reductions of glucose, uh, even cortisol that is secreted during the stress, even thyroid hormones that help for the that will help from the renal to the renal for the filtrations of minerals, even the waters in the kidney, and vaccines development and monitoring. ELISA we use it for the vaccines, assessing antibody levels post-vaccinations. And even ELISA we use it in drug monitoring, therapeutic drug monitoring, like measuring drugs levels in the plasma. Why we are measuring the amount of drugs that is in the blood or in the plasma, we use ELISA where these enzymes will detect the antibody that bind the antigens in that drugs. Even in the researches, through the investigation protein antigen antibody interactions, the ELISA we use it to detect those antigens and antibodies that are in the during the investigations or research. So here let's move on the vaccinations. Actually, vaccinations it's the injections of different in the body, the thing in the body that will activate or wake up the immunes to create the memories that will detect if any invaders attack the body, it will remind that the body that you have already had an antibody to fight against those foreign antibodies or antigens. So here we are going to look for the types of vaccines and their characteristics. There are different types of vaccines like live attenuated vaccines, inactivated vaccines, subunit vaccines, thyroid vaccines, messenger RNA vaccines, viral vector vaccines, and even conjugated vaccines. So here let's start on live attenuated vaccines. By looking at their characteristics, they are weakened pathogens that replicate in the host to elicit stronger and long-lasting immunity. For example, there is varicella and even yellow fever. So, inactivated vaccines, those are vaccines that are in the body but are not activated. The characteristics, there is killed pathogen that cannot replicate, they require boosters. Actually, there are the vaccines that are in the body, it's like killed pathogen that are in your body. So for them to work, they will require the boosters or the inhibitor, the enhancers. For example, there is those polio vaccines and hepatitis A vaccines. Subunit contain specific antigens such as proteins or polysaccharide within minimum side effects. For the example for that vaccines or for the subunit vaccine is hepatitis B and even HPV as human papillomaviruses. That is actually those viruses, those examples of viruses, HPV and human papillomavirus, they are transported through sexual contact or through sexual intercourse. even toxoids, inactivated bacteria toxins to protect against toxin-mediated diseases. Those are inactivated bacteria toxins that are in the body that will protect against toxin-mediated diseases. Examples, they are diphtheria and tetanus. So for the messenger RNAs, vaccines encodes pathogen protein that stimulate immunity, rapidly produce and non-infectious. These are the vaccines like that will come and enhance messenger RNAs that will generate the genes in the body that will encode to the pathogen proteins and it will stimulate the immunity. For example, there are COVID-19 that the COVID-19 vaccines like Pfizer and Moderna. So viral vector uses harmless viruses to deliver pathogen to induce immunity. Example of viral vector vaccines, there is COVID-19, AstraZeneca, and even J&J. So for conjugate vaccines, there is linked polysaccharide to protein to improve the activations of the vaccine or to enhance the vaccines to works. Example is HIV and even AstraZeneca as the COVID-19 vaccines. So let's move on start 9 for how does herd immunity contribute to disease preventions. Actually, herd immunity occurs when a significant portion of population is immune to a disease through vaccination or prior infection. This is when the different portion of populations are aware or are immune. Can't they be affected by different diseases? For those who had immunity, it will reduce its spread and protecting unvaccinated or immunocompromised individuals. For those people who are likely to be attacked by the diseases, for herd immunity, they will be prevented for those being attacked by the disease. There is mechanisms for herd immunity, how herd immunity contribute to the disease preventions. Immune individuals act as barrier, interrupting transmission chains as the reproductive number decrease, outbreaks become less likely. Threshold for herd immunity. The proportion of for immunity individual required depends on the diseases. For example, measles, as the range is 12 to 18, that means 19% of immunity needed, and COVID-19 for 70 to 18, and the immunity needed depend on variants for this by considering these percentages. Impact, reduced diseases burden and hospitalizations and even mortality. So let's move on on the last question for the difference between active and passive immunizations. By looking on different aspects like definitions, induction, onset of immunity, duration, even examples, we are going to look for the active immunizations and passive immunization. So by definitions, active immunization stimulates the immune system to produce memory cells. These active immunizations will remind or stimulate the immune system to produce those memory cells where it will recognize different antigens or different antibodies or different foreign antibodies in future times when there is any attack of pathogens. For the passive immunizations, by definition, provides preformed antibodies for immediate protections. And for the inductions, active immunization induces the via vaccines or natural infections. You can induct active immunization via or through vaccines or natural infections. While passive immunization is via anticellular or monoclonal antibodies. The onset of immunity as the time or the period it will take for those immunization to function. There is bit the delay for the active immunizations within days or weeks, while for passive immunization it will immediate it will immediately respond to the to the immunizations. And for the durations, in active immunization, it will take a long time, like years, different years. While for passive immunization, it is short-lived, weeks to months. Example for active immunization is vaccination. Example, hepatitis B. And for passive immunization, the example is antitoxins. For example, tetanus antitoxins, monoclonal antibodies, therapies, antibody therapies. And here is the clinical relevance. Active immunization is essential for long-term disease preventions, and passive immunization is used in emergencies such as exposure to rabies or venoms. While you are being bitten by the dog or the snakes, this passive immunization can be emergencies or can be the one that you can rely on to prevent those rabies or venom. So thank you. Uh, I can really appreciate your kind attention.